Hello future engineers, welcome to my YouTube channel. Here are continuation of problems given in algebra as quiz problems, which can also be problems to be given in the licensure exams of various engineering fields. If you want to anticipate the solutions to these problems, you may do so by pausing the video. So problem 16. A firm can sell at a price of 100 pesos per unit all of a particular commodity it produces. If X units are produced each day, the number of pesos in the total cost of each day's production is X squared plus 20X plus 700. How many units should be produced each day so that the firm is guaranteed a profit? So let's set up the formula for the profit. It should be sales minus the cost in a day. So the sales is simply unit price 100 times x, then this cost is given by this trinomial, and let's simplify this, and it should be greater than 0 to guarantee a profit. So negative x squared plus 80x minus 700 should be greater than 0, and we factor it into quantity negative x plus 10, x quantity x minus 70 greater than 0. We then determine the signs of these factors. First, this is 0 when x is 10, and the sign is positive when x is less than 10, such as 0, and negative when x is greater than 10 here. So that would be the signs. Then for x minus 70, x is 70 when x is less than 70, such as 0. So it is negative here up to 70, 0 at 70, then positive beyond 70. We then obtain the sign of the two factors as shown. So it's negative here because positive times negative is negative, negative times negative is positive, and negative times positive is negative. So since these factors should be greater than 0 or positive, then the solution would be 10 to 70 as shown. So open that at 10 and 70. So 10 is less than x and x is less than 70. So that's the solution, and it is C. 17. The first three elements of an arithmetic sequence are 20, 16, and 12. Which element is negative 96? So second, this is the first term 20, so 16 minus 20 equals 12 minus 16, and that's the common difference, which is negative 4. And the formula for any element is equal to first term, first element, plus quantity n minus 1 times common difference. So a sub 1 is 20, a sub m is negative 96 to find n. So am is a1 plus quantity n minus 1 times common difference. So a sub m equals a1 plus quantity m minus 1 times common difference. Substituting, negative 96 equals 20 plus m minus 1 times negative 4. And d is negative 4. So negative 96 minus 20, negative 116. Divide by negative 4. Then after that, plus 1. So that would be m is 30. So the element negative 96 is the 30th element. So that's the answer. Problem 18. A ball is dropped from a height of 12 meters. Each time it strikes the ground, it bounces back to a height of 3/4 of the distance from which it fell. So determine the total distance traveled by the ball before it comes to rest. So let us check if the distance fall or this total or the distance traveled it begins as it falls, then it rises. That's our first element. If these terms are in geometric progression, so this is the figure. So initial height is 12, then it rebounds to that height, which is 3/4 of 12, and 3/4 or 0.75 of 12 is 9. Then for the second rebound, it rebounds to 0.75 of 9, and that is 6.75. Then for the third, it is 0.75 of 6.75, and that is 81/16 meters. So therefore, our first term would be this 12 here plus 9. That's our first term. Our second term is 9 plus 6.75. And our third term is 6.75 plus 81/16. So let's check. Let's test if the distances are in geometric progression. So A sub 2. A1 is 12 plus 9, so 21 meters. A sub 2 is 9 plus 6.75, so it is 15.75 meters. And A sub 3 is 6.75 plus 81/16, and that is equal to 11.8125 meters. So let's check. Second divide by first. If it is constant, 15.75 over 21, is it equal to 11.8125 over 15.75? The answer is yes, it is 3/4. Therefore, R is 3/4. The sum of infinite geometric terms is first term over 1 minus R. A1 over 1 minus R. So substitute A sub 1 is equal to 21 over 1 minus 3/4. So therefore, the total distance traveled by the ball before it comes to rest is 21 times 4, and that is 84 meters. 19. In how many ways can 9 books be arranged on a shelf if 4 particular books are to be kept together? So this is arrangement by groups. So to determine the number of groups, so we have these 4 particular books, B1, book 1, book 2, book 3, book 4. Then in each succeeding shelf, we only have 1 book each, B5, B6, B7, B8, B9. So this is the first group, second, third, fourth, fifth, sixth. So there are 6 groups, and the first group has 4 members. So the formula is number of groups factorial times number of members in one group factorial times number of members of the other group factorial. But the number of members of the other groups is equal to 1, so 1 factorial is also 1, so it does not change. 6 factorial times 4 factorial. So substituting n is 6 factorial, 4 factorial. As I said, the rest would be 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial, so it's the same. So computing 6 factorial times 4 factorial, it is equal to 17 or 17,280 ways. Problem 20. A committee of 5 is to be chosen from 7 Republicans and 4 Democrats. In how many ways can the committee be chosen if it is to contain 3 Republicans and 2 Democrats? So the selection of 3 Republicans from 7 is a combination of 7 Republicans taken 3 at a time, because if we have Republican 1, 2, 3, and in any order, those 1, 2, 3 will be on the same combination. So that's why this would be combination. And for the other one, the selection of 2 Democrats from 4 is 4 combination 2. So therefore, the number of ways, or the number of committees consisting of 3 Republicans and 2 Democrats would be 7 combination 3 times 4 combination 2. And 7 combination 3 is 35, while 4 combination 2 is 6. So multiplying, that would be 210. Problem 21, how many different even integers can be formed from the digits 1, 2, 4, 5, and 8? So different even integers, there's no mention about the number of digits. So we have 1 digit, 2 digits, 3 digits, 4 digits, 5 digits. There are 5 digits given. So n equals the number of even integers with 1 digit, n1 plus n sub 2 plus n sub 3 plus n sub 4 plus n sub 5, where n2 is the number of different even integers with 2 digits, n3 the number of even different digits with 3 even integers with 3 digits, n4 is the number of even distinct integers with 4 digits, and lastly we have number of different even integers with 5 digits. There are 1, 2, 3, 2, 4, and 8, 3 even integers given, and we can say that the given integer is even if the last digit is even. So if it is 1 digit integer, then there are 3, 2, 4, and 8. For 2, by fundamental principle of counting, we first fill up the second position. This should be even, which is 3, and after we assign an even digit here, there will be 4 digits left. So there are 4 ways to assign a digit in the first position. By fundamental principle of counting, 4 times 3 is 12. Then n3, 3 bars. So 4 here, 3 here, 3 even integers, then 4, then 3. 4 left, then after assigning a digit here, there will be 3 digits left from 5. So 3, so 4 times 3 times 3 is 36. Then if there are 4 digits, we draw 4 bars. Then again, we first fill up this. There are 3 ways to assign an even digit in the last place. Then after that, there will be 4 left, 4, then 3 left, then 2 left. By fundamental principle of counting, 4 times 3 times 2 times 3 is 72. And lastly, if there are 5 digits, we draw 5 bars. We first fill up this, so 3 ways, so 4, 3 left, so 3 ways to assign a digit there, 2 left, so 2, then 1 left, 1. 4 times 3 times 2 times 1 times 3 is also 72. So therefore, the number of different even integers is equal to 3 plus 12 plus 36 plus 72 plus 72. And that is equal to 195. 22. Find the middle term of the expansion of quantity 1 minus x cubed y to the negative 2 raised to 12. N is 12. First term is 1. Second term negative x cubed y to the negative 2. And the middle term, so there will be 13 terms in the expansion. So the 7th term is the middle term. So m, therefore, because the middle term is the 7th term and m is r minus 1, so 7 minus 1 is 6. And the formula for m term is n combination m, first term to the n minus m, second term raised to n. So substituting, n is 12, m is 6, 7 minus 1, so 6, substitute here. 7th term is 12 combination 6, first term 1 to the 12, quantity 12 minus 6, second term negative x cubed y to the negative 2 raised to m, which is 6. So 1 to the 6 is still 1, negative 1 to the 6 is positive 1, x cubed raised to 6 is x to the 18, then y to the negative 2 times 6 is y to the negative 12. So the variables will be x to the 18 over y to the 12. The constant is 12 combination 6, and that is equal to 924x to the 18 over y to the negative 12. So the 7th term, or the middle term, is 924x to the 18 over y to the 12. which is D. Problem 23, find the term that does not contain x in the expansion of quantity x squared minus 2x to the negative 2 close to the 10. And if it does not contain x, it means it is the constant term. The first term is x squared. The second term is negative 2x to the negative 2. N is 10. M is to be determined, to be found. So our term is quantity 10 cm. First term x squared raised to 10 minus m. Second term negative 2 x to the negative 2 to the m. And we equate that to k, or constant. So that constant would be 10 cm and negative 2 to the m. So a sub r equals 10 cm times x to the 20 minus 2m negative 2 to the m, then quantity x to the negative 2m equals kx to the 0. So let's move negative 2 to the m here, the constant, 10 cm negative 2 to the m, x equals k. Because x to the 20 minus 2m, x to the negative 2m is x to the 20 minus 4m, and it should be equated to 0. So x to 0 because the term we are finding for is free of x, or does not contain x. So this is x to the 20 minus 4m, or 20 minus 4m equals x to the 0, so m is 5. 20 divided by 4. Having found m, then the constant term, which is this, substitute 10 combination 5, quantity negative 2 to the 5, and that constant term is equal to the sixth term, negative 8064. 24, what is the LCM of 80, 120, and 150? So we factor each first. 80 is 16 times 5, so 2 to the 4 times 5. And 120 is 12 times 10, so that would be 2 squared times 3 times 2 times 5. So 2 cubed times 3 times 5, 120. 2 cubed times 3 times 5, while 150 is 15 times 10, 3 times 5 times 2 times 5. So 2 times 3 times 5 square, 150. 2 times 3 times 5 square. Therefore, for the technique in finding LCM, it is the highest, even if not common. So for 2, the highest exponent is 4, so 2 to the 4th. For 3, it's 3, so 2 to the 4 times 3. For 5, it is 5 square. The LCM, therefore, is 2 to the 4th times 3 times 5 square. 2 to the 4th times 3 times 5 square. And that is equal to 1,200. The LCM is 1,200. So that's it for this video.